Alright, hey guys, I just recorded this, but the focus messed up halfway through, so I'm having to redo it. So what we're doing is eliminating the parameter and then writing that resulting equation in standard form. And the examples I have here, for example 1, x equals 2t plus 1, and then y equals 4t. And in this case, t is our parameter. X and y are functions of the variable t. T is our parameter. So first we want to isolate t. We'll just do it from x first, and then plug that resulting value in for y to get a standard form equation. So again, we're trying to solve for t from x. So x equals 2t plus 1. We'll go ahead and subtract 1 from both sides. So we get x minus 1 equals 2t. We'll then divide by 2 to both sides to isolate t. And we end up getting t equals x minus 1 over 2. That's our value for t, and then we take that and we'll plug it right into y equals 4t to get that standard form. So y equals 4 times x minus 1 over 2. We'll distribute this 4. And then these 4s will reduce. So we end up with ultimately y equals 2x minus 2. If you notice, that's a linear equation, y equals mx plus b. This is a line, linear line. That's redundant, but you're going to have a y-intercept of 0, negative 2, and then an x-intercept of 1, 0. So it's just a line. And now you've isolated it, the parameter, and expressed it in standard form. And then we can do another example. So say x equals 4 cosine theta plus 3. It's not blurry, is it? No. And then y equals 9 sine theta minus 2. So we're going to do essentially the same thing as we did over there, but this time it's important to remember a Pythagorean identity. One of our Pythagorean identities, the one with sine squared theta and cosine squared theta, which says that sine squared theta plus cosine squared theta equals 1. So we're really just trying to replicate that over here with this example too. So we'll begin with x, so we'll subtract 3. So we get x minus 3 equals 4 times the cosine of theta. And then we'll divide by 4. So we get cosine theta equals x minus 3 over 4. And let's go ahead and isolate sine theta as well. So we'll just keep this in mind. So we end up with y equals, well, actually, let's subtract 2, or add 2 rather. So add 2 and add 2. So we get y plus 2 equals 9 sine theta. And then we'll divide by 9. And we get sine theta equals y plus 2 over 9. That's our sine, right? And then, did I do these right? I think I did. Yeah. Yep, okay, sorry, I doubt myself. Then we can plug these into this Pythagorean identity. So it would be, start with sine. So y plus 2 over 9 squared plus x minus 3 over 4 squared equals 1. We won't mess with the top, we'll leave that squared, but we can actually then square the bottom. So we get y plus 2 squared over AB1 plus x minus 3 squared over 16, so we just squared the bottoms, equals 1. And I know I basically just used up the entire board to express that, but here is a standard form of these initial two equations that we started off with. I hope this is any bit helpful, and thanks for watching, guys.